Hello everyone and welcome to day 4 of Introduction to Computational Literary Analysis. Today we're going to learn more about if statements, we're going to learn about booleans, we're going to learn about lists and dictionaries. It's going to be really useful stuff. Here we go. Alright, so I'm going to open up a new notebook in Jupyter Lab again. I'm going to rename it 03. Lists and dictionaries, if lists and dictionaries. So last time we looked at for loops, and I briefly introduced an if statement here for you, but I want to talk about that in greater detail because this is a super important thing. So if statements have a certain anatomy. They start with if. They have some kind of test for equality. And they have a colon at the end. And then everything that comes inside the if statement happens here indented, and it has to be indented 4 spaces. You can also have a few other conditions. You can say elif, and then another test. You can also say else. So what this says is if this test evaluates as true, it's going to do this thing. It's not going to do anything else. And this says if the first one didn't work, try this one instead. And if that works, then you're going to do this and not do anything else. And this last one says if none of the other things worked, then finally do this last thing. Okay, so that's all very abstract, but it'll make more sense as we start to use this in real examples. Okay, so back here, I'm going through each of the words in the sentence, and I'm testing whether it's an alphabetic word or not, and if it is, I print that. Okay, so there are few things to note here. First, it must begin with if. Of course. 2, the test must evaluate to Boolean. So I'm going to show you what I mean by that in a code cell here. So before we had a string and we tested whether it was alphabetic or not. By using the isAlpha method. And when we test this, it evaluates as true. If something evaluates as either true or false, then it's evaluating to a Boolean, we say, and then it can be used as a test. So some other tests might be tests for equality. We could say AAA is equal to, and I use 2 equal signs here because this is the test for equality. If I were to use just 1 equal sign, Python thinks that I'm trying to assign something to a variable and it gets confused. So if I were to try AAA equals AAA, it says true. If I were to try AAA equals AAB, and again here I'm pressing Shift Enter to run the cell, it says false. Okay, so we can test equality using double equal signs. We can also test whether something is greater than something else by using the greater than sign. We can test whether something is less than something else by using the less than sign. And we can do a whole bunch of other things too. We can test whether something is not equal to something using this exclamation point and an equal sign. So here we're saying, is AAA not equal to AAB? And so because they're not equal, this is going to say true. Okay, so the test must evaluate to a Boolean expression. Then the code to run if true must be indented 4 spaces. And you can also optionally have an else which says what to do otherwise. Now again, if all of this seems very abstract, it's okay, because we're going to be looking at this in greater detail as we go through some examples. So let's make a little program as an example. So I'm going to say example, a program a program to see who stole the diamond. Okay, this is going to be a very what we call a contrived example. So I'm going to introduce in this example like a few new things. So let's first use this function called input to get user input. So input is kind of neat. I can say input, did you steal the diamond? And if I run this, you can see it gives me this little input box, and I can type something in here. And if I type something and press enter, all it does is just print out this value, because what's happened is input has stored whatever I typed in, but it hasn't stored it to any variable. So we can see the value, but we can't do anything with it. So to do something with this, I might assign this to a variable. I'm going to call it answer. So if I run this again, it says, did you steal the diamond? I could say, I did. And now you notice it doesn't print anything, but if I inspect the value of answer, either with the inspector, you can see here we're seeing the value. Or I can press Shift Enter here and it tells me the value is I did. I'm going to make this a little bit bigger. All right, so now we have a value that's stored here, but we want to do something else with that value. We want to say if the value is yes or yes-like, say one thing. If the value is no or no-like, say something else. So I'm going to say if answer equals yes colon, and again, here's an if statement. So we have answer equals yes, and this is a statement of equality that evaluates to a Boolean. So here we're testing to see whether answer is equal to the value yes. And again, the difference here is that double equals means test for equality. Single equals means assign the value on the right to the value on the left. So if answer is yes, we're going to say, quick, someone call Sergeant Cuff. We found the thief. However, if the answer is no, so in this case we could say else. Print, okay, move along then. Yeah, we might want to, instead of saying else, we might want to say elif answer equals no, print, okay, move along then. And then we could have a third one that would say I don't understand your response. Okay, so let's try it out. It says, did you steal the diamond? What happens if I say yes and press enter? It says, quick, someone call Sergeant Cuff. We found the thief. Okay, let me run this cell again. Try this again. If I say no, it says, okay, move along then. But if I run it and say certainly, it says, I don't understand your response. Let's try something where we answer yes, but it's not quite the yes that we're looking for. Did you steal the diamond? I'm going to say yes in all caps. And it says, I don't understand your response. So really what we need to do here is not test whether something is exactly equal to this, but test whether it's roughly in the same form. Okay, so why don't we modify this program to say if answer dot lowercase version of the answer equals yes, then we're going to call Sergeant Cuff. So what this will do is, no matter what we put in here, no matter what our answer is, whether it's uppercase yes, lowercase yes, or whatever, we are going to lowercase it, and then we're going to check that the lowercase version over here is equal to the lowercase version over here. So this will sort of solve this problem of us needing to make sure that our answer is exactly the same as what we're testing for. So did you steal the diamond? Let's try yes with a capital Y. Yep, and it correctly identifies us as the thief. What if we try uppercase yes? Yep, same thing happens. What if we try something like yes with a whole bunch of exclamation points after it? It says, I don't understand your response. So maybe we want to modify this a little bit. So we can use another method called starts with, and this is a string method. So we can say if the lowercase version of the answer starts with yes, then that's good enough for us. So let's try this. Did you steal the diamond? Yes, I did. And you see it only recognizes that the first three letters are yes, because we've used this starts with yes. So we can do the same thing over here with no if we want. And then if I were to put in no like this, it says, okay, move along then. So that's kind of nice. We've already made this into a little bit of a better program than it was originally. Okay, so so this works because starts with if we were to inspect this, what is it going to say when we take a look at starts with? So I'm going to look at contextual help here. Yeah, maybe if I try it like this. Yeah, okay, so contextual help says return true if S starts with the specified prefix. All right, so you can see here that it outputs a Boolean expression. So that means this is either going to evaluate as yes or no. So so let's see what answer is. Answer is no. So if I say answer starts with no, it evaluates to true. If I say answer starts with yes, it evaluates to false. So as you can imagine, we have starts with, we also have ends with, and we can use that kind of in the same way. Okay, so I want to show you another thing that we can do. We can test whether one string contains another or whether a list contains string using this amazing in keyword. Okay, so if we use the in keyword, we can test again whether one string contains another. So let's try to test whether yes is in oh my god, oh my god, oh my god, yes, I did steal the diamond. Let's test that. It says it's true because yes, the string is found right here. If we were to say yes in nope, 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 this evaluates as false. We can also do this with lists. So let's say we have a list of characters like Betteridge, Rachel, Rosanna. And now I want to test whether Betteridge is in this list. So I can say Betteridge in this list, Betteridge, Rachel, Rosanna. It says true. So you can imagine this is pretty handy. So what we can do is we can rewrite this little program of ours to use the in statement if we want to test for lots of different things at the same time. So I could say if answer is in a list like yes, yes. Actually, let me check whether the lowercase version of this answer is in these things. Did you steal the diamond? No, I mean yes. It says, okay, move along then, because it's checking whether something starts with no. Yeah, let me try this again. Did you steal the diamond? Yes. What it's done is check whether my response yes is in one of these versions of yes. So that's kind of neat because this allows you to come up with lots of different variations of something and look for every item in a variation without needing to write tons of if statements. Okay, so we wrote already a couple of fun little programs. Let's write another one where we ask the user for the user's name. So I could say, what is your name? And then I can greet this user appropriately. I could say, print hello, and then add answer, and then add something else. So let's try it out. What is your name? My name is Jonathan. Hello, Jonathan. How are you? Okay, so that's kind of nice. So what we've done here is concatenate these strings. We've added hello, and we've added answer, and we've added how are you. But another way of doing this, we could also write, and I'm just going to copy and paste this over here. I can introduce to you something called F strings. So I'm going to annotate this really quick. F strings are for formatting strings. So an F string is a string that starts with the letter F before the quotation marks. So I can say hello, and then in curly braces I can write the name of a variable. In this case I want to write answer. So what this does is Python says, okay, anything in curly braces, I'm going to replace that with the value of that variable. So it's going to print out this sentence, but it's going to stop at this and replace this with the answer that we've recorded in the previous step. So yeah, let's give it a try. I think it should evaluate to the exact same thing as that. What is your name? I could say Jonathan, and it says, hello Jonathan, how are you? So F strings are very handy. You can also put in other things here. So you could have it, what this does is kind of automatically translate this to a string. And so if answer were, for some reason, if it were an integer or something, it automatically translates it to a string. So this is really handy. Okay, so the next thing I want to take a look at is lists. So we touched on this a little bit already, but yeah, just as a review, you know, a list can be apples, oranges, bananas, and then number 3. A list can also have lists inside it. So here we have a list that contains another list. So this list might be 5, 6, 7. Okay, so if I were to copy and paste this into a new cell, you can see this is a list with 1, 2, 3, 4, 5 elements because it thinks that this 5, 6, 7 is one element. So I can use the len function, and it tells me down here that the len function returns the number of items in a container. I can use the len function on this list of fruit and numbers. And it tells me I have 5 things because this is 1, this is 2, this is 3, this is 4, and this is 5. So I can annotate this by saying lists can have all sorts of things, even other lists. Okay, let's say that we have a list and we want to get some stuff out of it. This is a pretty common pattern. So I can call this getting stuff out of lists. So in Python there's this term slicing. Slicing uses square brackets, which is confusing because lists are also defined using square brackets. And what this does is it gets us the item with a certain number. The tricky thing is Python counts starting at 0. So if we have a list and that list looks like apples, oranges, bananas, then actually this first one, apples, that's going to be item 0. The second one is item 1. And this third one is actually item 2. So this is kind of confusing. It takes a little bit of getting used to. Okay, so let's try this out. I'm going to make a new list, call it fruit, and I'm going to put apples, oranges, and bananas in this list. So now let's say I want to get the item apples out of this list. I could say fruit, the list, give it square brackets, and the square brackets have to be directly after the thing that you're slicing. So if I give it a slice of 0, this is going to say, okay, using this list called fruit, give me the 0th element of it. And the 0th element in Python speak is this thing called apples. So if I run fruit 0, it gives me apples. I can run fruit 1, and it gives me oranges, and so on. But I can also slice in other ways. You can slice using ranges that are colon separated. So if I want to get everything in this fruit list from the first item, which is oranges, to the second item, which is bananas, I can do fruit 1 colon 2. And you can read this like fruit 1 to 2. So what it does, you've noticed here, is it gives you up until but not including that last one. If I were to have a longer list of fruit, yeah, this might get me a few more. So a range with one item in it kind of doesn't make any sense. So why don't we take this fruit list and add a few more things to it. First, I want to show you that by using the dir method on fruit, we can get a whole bunch of stuff that we can do with a list. Okay, and again, underscore stuff you don't really have to worry about here, but the important things are we can append to the list, add things to the list, we can clear the list, we can copy the list, we can count certain items in the list, we can extend the list, we can index the list, we can insert things into the list, we can pop an item off the list, we can remove the list, we can reverse it, we can sort it. Yeah, let's try some of this stuff. So fruit, again, is apples, oranges, and bananas. What if I were to try to append something to this, like kiwis? Fruit.append kiwis. Now let's look at fruit and see what's happened. Apples, oranges, bananas, and kiwis. So you see it's added something to the end by using this append method. So I can't stress how important this is, because we're just going to be using this append method on lists just all the time. All right, let's try something else. Fruit pop. So let's look down here at the contextual help. It says pop removes and returns an item at the index which is defaulting to the last. So what it's going to do is take kiwis and pop it off the end of the list. So if I do fruit.pop, it says kiwis, right? It gives us the last item. But now if I look at fruit again, you can see it no longer has kiwis. Yeah, so let me append a few more fruit. Fruit append kiwis, fruit append, let's see, what's another fruit? Peaches. Now if I look at fruit again, I have 5 items. Let's say I want to get bananas, kiwis, and peaches. One thing that I can do is I can slice it, so I'm using square brackets again. I can start with 0, 1, 2. I want everything from the second element on to the end. So if I don't write anything here, that tells me I want to get everything until the end. And so you see I've gotten this slice of this list, which is bananas, kiwis, and peaches. I can do the same thing from the other side. I could say give me everything up until, but not including the third item, 0, 1, 2, 3. And it gives us apples, oranges, and bananas. So this may not seem very useful to you right now for text analysis, but it's in fact extremely useful because we can use this to get certain portions of a text. So you can imagine if you only want to get the first chapter of a text or the first 200 characters of a text, you can slice things using ranges like this. There's actually a lesser known feature where I can get something from fruit. I can get, say, like the second to the fourth element, but I can go backwards, or I can go via a certain number of steps. Okay, yeah, that didn't quite work the way I thought it would. Anything after the second colon is the number of steps. So yeah, maybe I can go from 1 to 5 in steps of 2. You can see it's sort of skipped around here a little bit. All right, so all of that stuff is known as indexing lists, or getting stuff out of lists. So we popped things, we've appended things. We can also count things in a list. So let's say I append a few more fruit to this. Append oranges, fruit, append oranges. Now I look at fruit again. So I have apples, oranges, bananas, kiwis, peaches, oranges, and oranges. So I have 3 instances of oranges. So if I use the count method, I would say fruit.count oranges, and this should tell me the number of oranges in my list. It says I have 3. So that's kind of handy. What else can we do? We can sort the list. So I could say fruit.sort, and now if I look at fruit again, everything is in alphabetical order. So that's kind of handy. So these are lots of things that we can do with lists, and I can't stress enough just how useful lists of things are, because especially when you're dealing with text, you're often dealing with things like list of words and list of letters, list of chapters. In fact, a lot of this stuff you can also use on strings too. So Python will allow you to write for loops over strings and for loops over lists in much the same way. So this is the cause of some confusion, and I'll show you what I mean. Okay, so let's write a for loop to go through each of our fruit items and evaluate it. So first I'm going to say for, and then I'm going to come up with a name for one of these things when I'm on it. So maybe I can call it like fruit item. It's confusing, because fruit is singular and plural. For fruit item in fruit. Now I'm going to treat things a little bit differently depending on what kind of fruit it is. I'm going to say if this fruit item is oranges, print I have oranges, yay, I love oranges. But if it's not that, I'm going to print I have fruit item, I guess. And here again I'm using an F string. And I have to remember with an F string, I have to remember to put this F in front. So again, what this is going to do is just give us the name of this fruit item as it goes through each of these fruits. So what it's going to do is this loop is going to go through each item in fruit, which is our list. And it's going to call that item fruit item when it's working with it. And then it's going to say, okay, if that fruit item is oranges, then say, I have oranges, yay, I love oranges. And And if it's not, it's going to say, I have, and then whatever that fruit item is, I guess. So let's try this. It should give us 1, 2, 3, 4, 5, 6, 7 lines. So it says, I have apples, I guess. I have bananas, I guess. I have oranges. Yeah, I love oranges. It says that 3 times. So lists and for loops are super common programming tools. And yeah, we're just going to see this a whole lot. Let's say, for example, that you have fruit, but it's not a list, it's like a string of things. This happens a lot. So it looks almost like a list, but this is actually a string. You see, if we put the cursor down here and look at contextual help, it says it's a string. Here's what the string looks like. The string is length 22. Yeah, that's something that I should mention, by the way. If we run the length command on this string, it tells us that the string is of length 22. That means it has 22 characters in it. If we run, if we were to run the same thing over here, it would tell us we have 1, 2, 3, 4, 5, 6, 7. And one thing that I didn't mention before is remember, if you notice over here on the side, each of these cells is run sequentially. So if I were to come all the way up here and evaluate this cell, now fruit is apples, oranges, bananas. If I were to inspect this, it says fruit is a list. And now if I were to come all the way down here and run this, you see fruit is this list because I ran that other cell, I executed that cell all the way up there. Now if I were to execute this cell, now fruit is a string, and now if I see what fruit is over here, now it's that string again. So the order in which you execute cells is pretty important, because you can change the value of something in the meantime, and you can get unexpected behavior that way. So if I run len here, it gives me the length of fruit is 22. If I were to run a for loop over this fruit, let's see what happens. It just prints out every letter, because what it's doing here is, if you run a for loop over a string, it treats each of the letters as items. So this is kind of like a strange behavior. If you ever notice that you're getting lots of individual letters, it's probably because you're treating a string as if it were a list. So that's one of the confusions that you might encounter in text analysis. Okay, but this is actually pretty useful because I can do some test where I could say, okay, depending on what letter we're on, if that letter is not alphanumeric, then replace it with something. So I could say, I'm going to call this fruit letter, because that makes more sense, because we're dealing with letters now. Okay, so I'm going to make some sort of test in here where I could say, if that fruit letter is alpha, then print it out. Apples, bananas, kiwis. Yeah, so that's kind of nice. What we've done there is we've effectively stripped out all of the spaces and stripped out all the punctuation. Now, what if we wanted to use our output instead of just printing it? Well, we can do one of these things where we make a new variable. We can call it new fruit. And instead of just printing it out, I could say new fruit equals new fruit plus fruit letter. So what this is going to do is, if it's alphabetic, it's going to take that letter and add it, like keep adding it to this new fruit string. So because it's an empty string that we've defined here, first time it runs it's going to be empty. And then if it is alphabetic, we're going to add a letter to it. It's going to add A. And it's going to keep going like that until it reaches the end. But it's going to skip anything that is punctuation. And it's going to skip everything that's a space because it's not alphabetic. So if we run this, and now we look at new fruit, you can see we've effectively kind of stripped this string of punctuation and of spaces. So that's already a neat feature of this, because what it allows us to do is, if we're not interested in punctuation marks, we can write a little for loop to clean up a string like this, which is a very common pre-processing technique in text analysis. So let's look at fruit again, and let's say I want to remove all of the commas but leave the spaces. So maybe I could use the same pattern. I'm going to copy and paste it here. And I could say if fruit letter is alpha, or fruit letter is space, then add it to this thing called new fruit. Now if we look at new fruit, we have apples, bananas, and kiwis. We've effectively cleaned up our text. Now, of course, there's a much easier way of doing this too. We can use a string method called replace. And the string method called replace can replace things like commas with spaces, for example, or commas with nothing. And if I were to look at fruit again, you can see that what it's done is kind of confusing. It's replaced it, but it hasn't actually changed fruit. That's because strings are in Python are immutable. That means you can't actually change them. You would have to assign them to something. So for this to work the way I expect it to work, I have to say fruit.replace commas with nothing is then equal to fruit. So this is something that you don't have to do with lists, right? So if I have a fruit list, you know, and it's apples, oranges, bananas, and if I were to append something to that list and then look at the list again, you can see the list is actually changed when I run append. However, if you have fruit and it's apples, bananas, and kiwis, and you want to replace commas with nothing, it gives you that response. But then looking at fruit again, you can see that it hasn't changed. That's because strings are immutable, and so to get this to work, we have to say fruit equals fruit.replace commas with nothing. And now if we look at fruit, you can see we have the response that we need. Okay, so I'm going to annotate this, and I'm going to say that this is a big difference between strings and lists. Warning, strings are immutable, lists aren't. And that means that running a method on a string doesn't change the original string. But it does with lists. Okay, great. So I have one more data structure, one more data type to show you, and that's dictionaries. So if you've ever done any programming in other languages before, you might know dictionaries as hash table. You might know a dictionary as a lookup table. And the reason it's called a lookup table is that it's an association of one value with another. So let's say that I have an inventory. So an inventory is usually the name of an item and the number of that items you have. So let's say I have apples, and I have 4 apples. If I were to write this in Python as a Python dictionary, it would look like this. So the anatomy of this is that this thing over here on the left is called a key, and this thing over here on the right is called a value. So I'm going to say dictionaries have keys and values. In other words, it's one value associated with another. Keys are usually strings. Values can be anything. They are separated with a colon. And key value pairs are separated with a comma. So here's a bigger dictionary. So apples, I have 4 of them. Bananas, I love bananas, so I have 500 bananas. Oh yeah, so I can add another one here, which says that dictionaries use curly braces. So whenever you see curly braces, chances are in Python we're dealing with a dictionary. So let's try this out. I could call this dictionary inventory, and I could say I have 4 apples, and for bananas I have 500, and for kiwis, note that I have to put this in quotation marks. For kiwis I have 2, because I don't like kiwis that much. So now that I have this inventory, if I were to put my cursor here, it tells me that this is a dictionary. It tells me it has a length of 3. So in other words, this is counted as one item, this is counted as another item, this is counted as a third. And let's figure out what I can do with this dictionary. So if I use the dir function, this is going to tell me all kinds of things that I can do with a dictionary. So let's ignore all of this double underscore stuff, and look here, we can clear it, copy it, we can get an item from it, we can get all of the items, we can get all of the values, get all of the keys, we can pop an item, we can do all kinds of stuff with it. So let's play around with this a little bit. So inventory, what if we just run inventory on its own? It just shows us a representation of the dictionary. What if we do inventory dot get apples? What's this going to do? Well, the inspector tells us that it returns the value for a key if the key is in the dictionary, else the default value. So the default value is none, which is a data type that we haven't really talked about yet. Okay, that's great. What if we were to do inventory get the number of bananas? It says I have 500 bananas. Okay, so what else can we do with this inventory? We could say, let's try keys. So here it tells me that keys gives us a set-like object providing a view of the dictionary's keys. So it says that I have apples, bananas, and kiwis in my inventory. If I look at all of the values, here it says it provides a view of the dictionary's values. It says I have 4 of something, 500 of something, and 2 of something. And what if I were to try inventory items? Here it gives us a list of these pairs. These things are called tuples. They're kind of like a list, but a little bit different. So this is kind of neat. This means that we can iterate over this in certain ways. So, you know, just like you can run a for loop over a list, and just like you can run a for loop over a string, we can run a for loop over a dictionary too. So we could say for fruit item in inventory, print fruit item. Let's just see what this does. It prints the keys, and it only prints the keys. So what if we were to write something that says I have and then blank apples? So remember that we can do inventory.get on something like apples, and it tells us how many we have. It tells us the value associated with this key. Another way of doing this is we can slice it and get the value out of it. So we use this kind of slice syntax here and say inventory slice apples, and this tells us that we have 4. The get function is kind of a little bit better, you know, because if I were to have typed apples wrong, it tells me just nothing. However, if I were to do the same thing with this, I get an error, and it's a key error. It says that key doesn't exist. So sometimes you want an error because that means that it forces you to go back and rewrite it. Sometimes you don't want that error though. So it's a key difference which one of these you use and for what purpose. So let me write my for loop again. I could say for fruit item in inventory, print. Now I'm going to make an f string here, and I'm going to say I have, and then I'm going to get that value out of this. So I'm going to say take my inventory and get that fruit item out of it. So I'm slicing it, then I'm putting it in my f string, and then I'm going to say the name of the fruit item. So here I'm getting the value of that particular fruit item. Here I'm getting the name or the key of that fruit item. So if I run this, it says I have 40 apples is, bananas is, kiwis is. Okay, so I forgot that these are plural, so I don't actually need that s. So I can rewrite it to say I have 4 apples, I have 500 bananas, I have 2 kiwis. So that's kind of neat. If I were to write this in a more long form way, just to make it more explicit what I'm doing, I could also write it like this. Number of fruit item is inventory fruit item. And I could also write this print I have plus number of fruit item plus fruit item. And is that going to work? It doesn't work because it says it can't concatenate strings and ints. So this is because number of fruit item here, this is because this value is an integer, and it doesn't know how to add strings and integers, right? You remember we can't do something like this, fruit plus 3, because it doesn't know how to add these two things. But if we were to say fruit in quotation marks plus 3 in quotation marks, it can add them like that. So to fix this, we would need to come up here to number of fruit item and convert this to a string. So this is something that the f string does automatically, but if we were to write this long form, we would need to do that manually. So we can see here it hasn't added a space automatically, so maybe that's something that we want to add ourselves. So if I use quotation marks and put it around a space, now it gives us the output that we want. I'm just going to clear some of these things. So I'm going to write this down more explicitly because these are super important, very common patterns. I'm just going to write getting something out of a dictionary. And to do that, we would take our dictionary like inventory, give it a key, and then this returns a value. But we can also do this in reverse, right? So I can put something in a dictionary in the same way. So I'm going to annotate this by saying putting something in a dictionary works the same way. So if I say, if I have inventory apples and I assign it to something, let's say I want to tell it that I have 6 apples. Right now inventory apples tells me I have 4 of them, but if I were to say assign that to 6, now if I were to look at the inventory for apples, it would tell me I have 6 of them. I can also increment this just by doing something like this. So take the original value and add 1 to it. Now let me look at how many apples I have. It says I have 7. Now if I were to run this cell again and look at it again, it says I have 8 because it keeps taking the old value and it keeps adding a new one to it. So that's how I can change the values in a dictionary. So yeah, what else can we do with dictionaries? We talked about adding to them. We talked about getting values out of them, checking if items are in them. We haven't really done that yet. So we can use this in keyword to check whether items are in a dictionary too. So I could say check whether an item is in a dictionary using the in keyword. So do I have apples in my inventory? It says true, I do. What if I say, do I have dragon fruit in my inventory? It says false. So a very common pattern is to do something like construct a counter that is a dictionary. And so a counter will have the number of items that I have as values, and as keys is going to have the name of that counter. So I first start with this empty dictionary, and then I could go through some item in a fruit list. Let me see if I still have this fruit list item. Yep, so for item in my fruit list, I'm going to call this fruit item to make it more semantic. I'm going to add this to my counter. And to keep counting items for however many items I have. So to get this into some good test data, I'm going to run this a few times running that cell a few times, and now let me look at my fruit list again. And now I have 1, 2, 3, 4 oranges. So I want to make a counter to count the number of oranges in my fruit list, to count the number of everything, really. So I'm going to go through each item here, and then I'm going to add 1 to that item in my list. So this is not going to work at first because it says that it doesn't have apples in my list. So one way to do this is to say, to initialize the list with 0 values, and now if I look at my counter, it says I have 1 apple, 4 oranges, 1 banana, and 1 kiwi. This is exactly what I want to happen, but this is a lot of typing. So instead of doing that, I could start with an empty list, and I could say for fruit item in fruit list. Now first I check to see whether the item is in the list. So if fruit list fruit item, let me write it like this. If fruit item is in the counter already, then we're going to take counter's fruit item and we're going to increment it. So add 1 to it. And that's if it's already in the counter. But if it's not in the counter already, then we're going to have to add it to the counter. And we'll give it a value of 1 because we're seeing it for the first time. So if we run this, and now if we look at the value of counter, we've done the same thing as before, only now we're checking to see whether an item is in there already. So this is a very, very common pattern, and because so much of what we do in computational text analysis is counting words, it's good to keep this pattern in mind because this is the kind of thing that we're going to be using quite a lot. Okay, so today we've covered so much, and this might be the kind of lecture that you have to watch a second time, just because there's so much really important stuff here. We've done if statements, we've done a little program here where we get input, we use if statements. We've looked at in keywords for testing whether something is in something else. We've looked at formatting strings. We've looked at lists, how to get stuff out of lists, how to put stuff in lists, and we've looked at dictionaries. Yeah, so one last thing that I want to introduce to you before I sign off is that dictionaries can also contain other things. So a dictionary can contain a list. For example, if I had 4 apples on Monday, 5 apples on Tuesday, etc., I can write a list as the value of apples. I can write a list as the value of oranges. And assign this to an inventory. And I can chain slicing on this. So if I wanted to get the value for apples from this inventory, I could write that, and it gives me this list because this is the value of the apples here. And I can also slice what comes after. So if I want to get this number 5 out of the inventory, I could chain these two, where I could say inventory apples, and then I actually want to get 0, 1. I want to get the first element out of this list. So inventory apples 1 is 5. So what I'm doing is I'm drilling down twice. I'm saying, okay, first give me the apples value, then give me this 5 value. So this is going to be something that appears on the homework. Yeah, so I'm going to post the homework just momentarily. And the homework is going to have 8 problems, and they should they're designed to familiarize you with a lot of these patterns. Some of the stuff will be very tricky at first, so keep in contact, in the chat, and yeah, we'll work through it together. Also, tomorrow on Friday, we have the open lab meeting, so do stop by and ask any homework questions that you have there. Okay, great. Yeah, this has been a long lecture, but hopefully a useful one. And yeah, I might see you tomorrow, but if not, I'll see you next week for week 2.